welcome back. Today we are going to discuss the questions related to Hardy-Weinberg equilibrium. So before we begin, let us revise the two equations that I have told you in my previous video regarding the Hardy-Weinberg equilibrium. The two equations were P plus Q is equal to 1 and the other one was P square plus Q square plus 2PQ equals to 1. So in this equation, this equation will tell you about the allele frequency and this one will tell you about the genotype. So in this, the P is telling you about the frequency of the dominant allele and the Q will tell you the frequency of the recessive allele. Similarly, in this equation, P square will tell you the frequency of homozygous dominant persons and this will tell you the frequency of homozygous recessive persons, and the 2PQ will tell you about the heterozygous people or the carrier. So now let us begin with the question. The first question says the frequency of the two alleles in a gene pool is 0.19 for the capital A dominant allele and 0.81 for the small a recessive allele. And we have to assume that the population is in Hardy-Weinberg equilibrium. So the first part is calculate the heterozygous individuals in the population in the form of percentage. And the second part is percentage of homozygous recessive in the population. So first of all, what we have to do, we have to write the things which are given. So 0.19 is the frequency of a dominant allele. So this is our P value and 0.81 is the value for Q. So now we have to calculate the percentage of heterozygous individuals in the population. As I have told you, heterozygous individuals are to be calculated by 2PQ. So we just need to put the values here and it will come out to be 2 into 0.19 into 0.81. So this will give us the value which is equals to approximately 0.31. And when we will convert this into percentage, so how do we convert it into percentage? We just need to multiply it with 100. So the answer would be 31%. Similarly, the percentage of homozygous recessiveness in the population is to be calculated. Now, homozygous recessiveness, how do we calculate it? It is homozygous recessiveness. So it will be Q square. So just take the value of Q and calculate the square of it. This will give you the value which is equal to 0.6561. Now when we will convert it into percentage, just multiply it with 100. So this will give us the value into 100. When we will do into 100, the value will come out to be 65.61, which is equal to approximately 66%. So now let us move to the next question. So the next question is, an allele W, capital W, for white wool is dominant over allele small w for black wool. That means what is it given? That capital W will tell us about the white wool, and small w will tell us about the black wool. Okay, so it is given that it is wholly dominant over small w. In a sample of 900 sheets, 891 are white and 9 are black. Now we have to calculate the allelic frequencies within this population, assuming that the population is in Hardy-Weinberg equilibrium. In this type of question, always when the number of quantity is given, we need to find the frequency first. So how do we calculate it? First of all, just because capital W, which is for the white wool, and small w is black, and capital W is dominant over small w. So in the equation, P square plus 2PQ plus Q square is equals to 1. So this whole will give us the value for the white wool, and this one will give us for the black wool, just because it is wholly dominant over the other allele. In this type of cases, we need to start from the recessive allele. So we have to find the frequency of Q square. How do we calculate it? Just the given quantity is taken to be in the numerator, and we have to divide it with the whole number, and the whole number is 900. So it will come out to be 9 divided by 900, which will come out to be 0.01. So the Q square value is 0.01. So the Q value will come out to be the under root of 0.01, which is equals to 0.1. Now we know the equation, which is P plus Q is equals to 1. We can calculate the value of P now, because we know the value of Q, which is equals to 1 minus Q. So it would come out to be 1 minus 0.1, which is equals to 0.9. So what we would be asking in the question is, calculate the allelic frequency within this population, assuming that the population is in Hardy-Weinberg equilibrium. So the Q value is 0.1 and the P value is 0.9. Hence the question is solved. Let us come to the third type of question. The third question is, in a population that is in Hardy-Weinberg equilibrium, the frequency of recessive homozygote genotype of a certain trait is 0.09. We have to calculate the percentage of individuals homozygous for the dominant allele. So what it is given in the question is the frequency of recessive homozygote genotype, which means the value which is given is Q square, which is equals to 0.09. So the Q value is 0.3. And what we are asked? The percentage of individuals homozygous for the dominant allele. So what is it asking? It is asking the value of p square, because this represents the frequency of the homozygous individuals for the dominant one. So the percentage of individuals homozygous for the dominant allele, we have to calculate the value of p, which is equals to 1 minus 0.3, which will come out to be 0.7. So the p square value will be 0.7 square, which is equals to 0.49. Now again it is asking in the form of percentage, so we will multiply 0.49 with 100, which will come out to be 49%. Hence the question is solved. So in this question it is said, in humans the Rh factor genetic information is inherited from our parents, but it is inherited independently of the ABO blood type alleles. In the humans, Rh positive individuals have the Rh antigen on their red blood cells, while Rh negative individuals do not. There are two different alleles for the Rh factor known as Rh positive and small r. We have to assume that a dominant allele is capital RH and it produces the phenotype Rh positive, and the recessive small rh allele produces the Rh negative phenotype. In a population that is in Hardy-Weinberg equilibrium, 160 out of 200 individuals are Rh positive, and we have to calculate the frequency of both the alleles. So in this question, it is given that Rh is capital Rh is dominant over small rh, and it is seen because it is wholly dominant. Again, p square plus q square plus 2pq is equals to 1, and here p square and 2pq will tell us about the RH, this one, and small rh is about q square. So first of all, it is given 160 out of 200 individuals are Rh positive. So the people with individuals without the Rh is Rh negative phenotype is 200 minus 160, which is equals to 40. So the frequency for the recessive homozygous people are q square is equals to 40 upon 200, which comes out to be 0.2. Now for calculating the frequency of both the alleles, we have to calculate the value of q first. So q square is 0.2, so q will be equals to under root of 0.2, which comes out to be 0.45. So if q is equals to 0.45, the value of p will be equals to 1 minus 0.45, which will come out to be 0.55. Hence the question is solved. Let us move to another question, which is, Two Siamese and three Persian cats survive a shipwreck and are carried on a driftwood to a previously uninhabited tropical island. All five cats have normal ears, but one carries the recessive allele small f or folded ears, and his genotype is capital F, small f. Now we have to calculate the frequency of alleles capital F and small f in the cat population of this island. And the second part is, if it is in a Hardy-Weinberg equilibrium for these alleles, about how many cats would we expect to have folded ears when the island population reaches to 20,000. So, and how we have to calculate it. So now what it is given, 2 Siamese and 3 Persian cats. So total cats would come out to be 5. Okay, and it is given that all have normal ears, but one carries the recessive allele small f or folded ears, and his genotype is capital F, small f. So out of 5, 4 and 1. This 4 will have capital F, and this one will have capital F, small f. Okay, so we have to calculate the frequency of alleles capital F and small f in the cat population of this island. So because here capital F is 4, so how many alleles will be there? Just we have to multiply by 2. So it will come out to be 4 into 2, which is 8. So 8 is the value for capital F allele in this one, and in this one it has one capital F and one small f. So the total comes out to be capital F is this 8, and this one will come out to be 9, is 9, and small f is equal to 1. So the total alleles will come in the population is 9 plus 1, and the frequency for the capital F will be equals to 9 upon 9 plus 1, that is 0.9, and small f, this is for the frequency of capital F, and the recessive will come out like in this case we can calculate with the help of this technique, or we can calculate directly with the formula. So this is 0.9, which is equals to the frequency of the allele of the capital F, which is p value. So the q value can be calculated as p plus q is equals to 1. So the q value will come out to be 1 minus p, which is equals to 1 minus 0.9, which is equals to 0.1. Okay. So we have calculated the first part, which is the frequency of allele capital F and small f. Now we have to calculate, if we have to assume that Hardy-Weinberg equilibrium is there for these alleles, and we have to calculate how many cats will be having the folded ears. So folded ears will be having the small f allele. So for this again we have to do by, we have to calculate first the q square, which is equals to 0.1 square, which will come out to be 0.0 1, and because the total population is 20,000, so we have to multiply with this value with the 20,000. 0.1 into 20,000, 20,000, which will give us the value 200 cats. Okay, now let us move to the next question. The next question is, in a certain African population, 4% of the population is born with the sickle cell anemia, small a, and we have to calculate the percentage of individuals who enjoy the selective advantage for the sickle cell gene, increased resistance to malaria. So first of all, it is given that 4% is born with small a. So the Q square value is 4 upon 100. Why 100? Because it is given in percentage. So out of 100, 4 people are having this type of genotype. So Q square value will come out to be 4 upon 100, which will be equals to 0.04. So the Q value will come out to be 0.2. And we have to calculate the percentage of individuals who enjoy the selective advantage of the sickle cell gene. So first of all, I would like to tell you that selective advantage of the sickle cell gene, people which are having small a gene will have the sickle cell anemia and eventually they will die. But the people who are having the allele capital A and small a, which means they are heterozygous, so these type of people will have the advantage that half of the allele will produce the normal hemoglobin and half of it will produce the sickle cell anemia hemoglobin, which means the half of the hemoglobin will be sickle shape. So this half which is having the sickle shape will be resistant to the malaria, and in this way they will have an advantage that they are resistant to malaria and are also producing the normal hemoglobin. So the 2pq value will come out to be 2 into 0.8 into 0.2, which is equals to 0.32. Because we have to calculate it in the percentage, so the answer will come out to be 32%. So this was all for the questions, and I hope you enjoyed it. Please join my Telegram channel for the quizzes and instant help, and link is given in the description below. And also I am attaching one Google form for some other questions which I have given related to Hardy-Weinberg equilibrium. You can comment down the answers in the comment box, or you can also tell the answers in the Telegram channel. But you have to tell me with the help of the explanation. And also those who will give the correct answer for all the questions, they would be given the shout out in the next video. So thank you for watching.